Hello students, welcome back to our channel. Today we will discuss a problem that came in JEE Advanced 2020, and this is the problem of Rolle's theorem. Using Rolle's theorem we can solve this problem very easily. First students, you should pause this video and try yourself, then you can see the solution. Okay, now look at this problem. Is be a set like that x square minus 1 whole square and a polynomial a0x, a0, a1x, a2x square, a3 x cube, and f and f double dash with the denotes its first and second derivative respectively. Then the minimum possible values of mf dash and mf double dash, where f belongs to s and mf denotes the real roots of this polynomial f. So we will solve this problem using Rolle's theorem. So students, first we will see what is Rolle's theorem. So Rolle's theorem says that between any two roots of fx, there exists at least one root of f dash x. That is, suppose f be a polynomial like that. It has two roots at alpha and beta. This is fx. Then Rolle's theorem states that between alpha and beta there is a root. Suppose gamma be the root here, and f dash gamma is equal to 0. So gamma is the root of f dash x. Actually, students, look at this point. This is the point of local minima. So if we draw a tangent here, so this will be parallel to the x-axis. That's why f dash gamma becomes 0. So this is the geometrical interpretation of Rolle's theorem, and we will use Rolle's theorem to solve this problem. Okay. Now, first, look. So since f belongs to s, f must be is of the form x square minus 1 whole square and a0, a1x, a2x square, a3 x cube. So this is fx, and we write fx in this form: fx equal to, and suppose this is my gx. So fx is a combination of two polynomial. Okay. Now, as we can see that f has the roots of fx is in multiple root, because just look at this thing. This is x plus 1 whole square and x minus 1 whole square into gx. Okay. So root of fx is a multiple root, because 1 arises here 2 times and minus 1 also arises here 2 times. Okay. And we need not check about the roots of gx, because in this question, look at this line, the minimum possible values of mf and mf double dash. So as we are asked to find the minimum possible values of mf and m double dash f, we don't need to check about the roots of gx. We can assume, we can predict the roots of gx, but in this question it's not necessary. This is not important. Okay. So just let this is as hx, and the roots of hx will be the roots of fx, and we will discuss about the roots of hx. Okay, so let hx equal to x plus 1 whole square into x minus 1 whole square. Now look, at x equal to minus 1 and x equal to plus 1, h is becomes 0, and minus 1 is a multiple root of order 2, since x minus 1 is wholes in the form of square, and x minus 1 is also in the form of square. So the graph of hx will be look like this. At x equal to minus 1 and x equal to plus 1, graph of hx will be look like this. It will touch x-axis at the point minus 1, and it will go upward. Then again it touch at x equal to minus 1, and it will go upward. Because as x tends to plus infinity, hx tends to plus infinity, and as x tends to minus infinity, as we can see that hx also tends to minus infinity. So the graph will become from start its journey from above the x-axis, and it will touch at x equal to minus 1. Then it will go again once again upwards. Now it is very interesting to see that as x equal to minus 1 is a multiple root, so in that point discriminant must be 0. And one more thing is that at x equal to minus 1, this x-axis become its tangent. Okay, so once again so since x-axis become its tangent, so we can say that at f dash minus 1 is equal to 0. Okay, sorry, this function is hx, sorry, so we let this function is hx, so h dash minus 1 will be 0. Okay, because at x equal to minus 1, these x-axis become its tangent. Okay, for its multiple root. Okay, at x equal to minus 1, and similarly at x equal to plus 1, once again these x-axis becomes its tangent of hx. So here also is, we can say is, so without using Rolle's theorem, just using this graph, we conclude that minus 1 and plus 1 is the, sorry, minus 1 and plus 1 is a root of h dash x. Now as also we can see that at x equal to minus 1, h x also 0, and h is equal to plus 1, here hx is also 0. So between minus 1 and plus 1, we also have a root of h dash x, and in this case we will apply Rolle's theorem, because at minus 1 in and plus 1 is the root of hx, and between these 2 points we will have a point beta where h dash beta is 0. So from this structure already we have concluded that h dash x has three distinct real roots. Now we will go for h double dash x. Now, so hx is of the form x square minus 1 whole square. So h dash x equals to 2 into x square minus 1 into 2x. So as x tends to plus infinity, h dash x will change to plus infinity, and x tends to minus infinity, h dash x tends to minus infinity. So the graph of h dash x will be look like this, because as we already know that h dash x has three distinct real roots, and as x tends to minus infinity, h dash x tends to minus infinity. it will go from here and then finally it's go upward because it's tends to plus infinity as it x tends to plus infinity, it tends to plus infinity. So this is my minus 1 and this is beta and this is plus 1. That already we have concluded this from Rolle's theorem, and this is the graph of h dash x. Okay. Now we are going to apply Rolle's theorem once again on h dash x. So between what Rolle's theorem says, between any two consecutive root there exists a root of f dash x. So between any two consecutive root of h dash x, there must exist a root of h double dash x. So minus 1 and beta is a and beta and 1 are the consecutive roots. So we can easily find here a gamma and a delta as a root of h double dash x. Okay. So applying Rolle's theorem, we can say that if uh, h h dash h double dash gamma equals to 0 and h double dash delta is also 0 where gamma lies between minus 1 and beta and delta lies between beta and 1. So this is very clear from these two graphs that h dash x has three distinct real roots and h double dash x has two distinct real roots, that is gamma and delta. So as we have already told that the roots of this part gx is the roots of fx, because this is in this just product of two polynomials and we ignore gx, and so uh, mf will be mf dash will be 3 and mf double dash will be 2. So the minimum value of mf dash plus mf double dash will be 5. Okay.